Right. Hello. Welcome to ChiPy. So my name is Heather. You can find me most places on the internet as Evil Weasel. And today I'm going to talk about Python for Java developers. So apparently most people using this mic aren't as short as I am. So to introduce myself, I'm an organizer for Chicago Python user group. I like to work on open source projects in my spare time. Most recently, I've been doing a lot of work with packaging for Python and Rust and Debian. And I'm one of the organizers for the Chicago Debian Python. We got an echo. Okay. For the Chicago Debian Python SIG, so if you want to know more about Debian packaging, come talk to me. More importantly, this is by cat. All right, so our hosts had asked if we could give an overview of Python for people coming from Java. And there are some obvious things that you'll notice just looking at code from the two languages, things like syntax. I'm not going to focus so much on that. I'd rather go into details that you'll encounter as you're working in Python. Most specifically, I want to focus on typing and objects and some common misconceptions about each. But also, if we're going to do a fair comparison between two languages, it's worth saying there are reasons that Python and Java look the way they do. So most people are, at least the internet is familiar with the origin story about how Guido van Rossum created Python as a project over the holiday break in 1989. And his goals were to create a simple and easy to use tool between the shell and C. By contrast, James Gosling and the team at Sun Microsystems was trying to make a tool that would make large projects managed by teams safer. So if you're looking at why does Java do this and why is it so very explicit and low level, well, that was the problem they were trying to solve. So it's interesting. It's sometimes useful to keep that in mind when you're looking at a tool and saying, why does it work the way it does? So anyway, to move on to typing. We hear that Python is dynamically typed and Java is statically typed. And when we talk about what that means, there seems to be this assumption that static typing is stronger than dynamic typing. That's not the case. Essentially, static typing means that when you declare a variable, you assign it a type and it doesn't change. Dynamic typing means that at runtime, the type of an object can change. Essentially, you have a type and it's associated with a value and not necessarily a name. And the value associated with that name can change. Now, when we talk about strong typing, what we mean is that if you want to cast a value to a new type, it has to obey certain rules. Both Python and Java are strongly typed. Now, the counter case to that is if we look at JavaScript, which is kind of famous for type coercion. If we try to add 5 and 2, if one of these values is a string and the other one is an integer, we're not going to get 7, we're going to get 52 because the integer got coerced to a string and it concatenated. So to look at some examples, here we have the Python REPL, and we can see that if we cast a numeric string to an integer, we get an integer. That's allowed. However, if we try to cast an alphanumeric string to an integer, we're going to get a value error. And if we just, for whatever reason, decide to try to call int on a list containing an integer, we're going to get a type error. And of course, we also get a type error if we try to add a string and an integer. Another thing we hear about with types is optional typing. Now, typing is not optional in a strongly typed language. What this refers to is actually type annotations, which are not actually used at runtime. These are hints that allow us to run static analysis tools against Python code. So if we look at my example here, I have a function named foo that is annotated that is supposed to accept an integer and return an integer. However, if I call it with an alphabetical string, it's going to give me back an alphabetical string without an exception. So we can see, obviously, the type annotations didn't do much. So the last thing I'd like to talk about is objects. We always hear that everything in Python is an object. Now, if you look at StackOverflow, you may encounter people talking about old versus new style classes. You don't have to worry about old style classes. They're no longer around. Everything in Python inherits from the object metaclass. Now, why that's important is that the object metaclass contains the dunder methods that define the object life cycle and behavior. And essentially, that's what makes Python objects work the way they do. Now, an interesting and possibly dangerous result of this is that because everything inherits these using, well, inheritance, we can override them like any other method. And so because these define how Python operators work, this is different than Java, where you cannot overload operators. So an example of this, if we take another integer, we can check with isInstance, is it an instance of object? It says true. And if we call the dir method on our integer, we'll see all of the attributes on that instance. Now, I can't go ahead and assign the dunder add method my foo function from my last example because the dunder add attribute is read-only. However, I can inherit from integer and redefine the dunder add method on my new class. Generally, it's not a good idea to override dunder methods. You can do this, and it's very powerful functionality, but it can also make your code behave very unpredictably in ways that people wouldn't look for. So there's obviously more about these languages than I can cover in 20 minutes, but I hope I've given you at least a good place to start and some ideas of things to look into when learning about Python. So with that, does anyone have questions?